Okay, there you go. Today is quiz day, so quiz 9 is due in D2L, and then in quiz 8, we're going to do antiderivatives today. So we've made it over the hump. We're just going to coast to the end of the semester. So an antiderivative is sort of the undoer of the derivative, right? So we know how to take derivatives. Antiderivatives just undo all of those things. What you want to think about when you think about an antiderivative, though, is the fact that when you take the derivative of a constant, what do you get? Zero. So when you undo a constant, undo a zero, you can get lots and lots and lots of different constants, right? So when we find an antiderivative, we don't find just one. We find a whole family of functions because we can add any constant we want at the end. And when we take the derivative, it'll still be the same because the derivative of whatever constant we add to the end is going to be zero. So in an antiderivative, we find this whole family of functions. So a function, capital F, is an antiderivative of little f if the derivative of capital F equals little f. We say this notation indefinite integral. So this is the notation you're going to see a lot, this indefinite integral here. So if capital F is a function where the derivative is little f, then the indefinite integral or the antiderivative of little f is capital F plus c. That's that constant, that family of derivatives, and that's called the general solution. On Wednesday, we're going to work on what happens if they tell you some more information about the function. Can you find that c? Can you find what's called a particular solution? We call c the constant of integration. It's random. It could be square root of 2, it could be 1/2, it could be -10, right? C is lots and lots of different numbers. When you think about these functions here in blue, they all have the same derivative. What does the derivative represent about a function? The rate of change, the slope, right? All of these lines have the same slope. So their derivative would be exactly the same. So they are all antiderivatives of the same function. Okay, so derivatives and antiderivatives are inverses, they're undoers. So all of the rules that you know about derivatives, you can undo them to get the rules about antiderivatives or integrals. So the derivative of a constant times x is just a constant, which means that the antiderivative of a constant is that constant times x. The power rule says bring the power in front and subtract 1 from the exponent. When we undo that, we add 1 to the power and then divide by the new power. The derivative of sine is cosine, so the antiderivative of cosine is sine. The derivative of cosine is negative sine, so the antiderivative of sine is negative cosine. So these are all just those basic like undoer rules. What I want you to sort of remember about antiderivatives is there are no product rules, there are no quotient rules, there are no chain rules. Okay, the only thing we have are the addition and subtraction rules. If you have a bunch of functions added or subtracted together, you can take their antiderivative in individual pieces. If you have two functions multiplied together, there is no product rule. You can't just do an antiderivative that way. Calculus 2, the whole like first 6 weeks are all about taking integrals or antiderivatives of these different functions, okay? Turns out like 99% of the stuff you see, sorry?
First 6 weeks?
Of calculus 2, yeah. Turns out like 99% of the stuff you see, you can't even take the antiderivative of. Yeah. So, okay, so we're going to try it. It says find the antiderivatives of the following functions. I traded out my jacket for like a heavier one. I had the lighter one on. It's a tough day out there. Okay, find the antiderivatives of the following. So just like with derivatives, the best plan for you to do it is to rewrite them so that they look like your rules, right? Here's our table of rules. Here's all our integration formulas. We want to rewrite everything we see so that it looks like one of these things from our table. Okay, so how can I rewrite the first piece? Oh gosh. Oh gosh. What's happening? Okay. Okay, f prime of x is 4 times x to the what? 2/3 minus 5 times x to the -3/5. Yeah, it's negative because it came from the denominator. It's 3/5 because the exponent was 3, and then I took the 5th root. So -3/5 plus 2. Okay, so f is the antiderivative of this function. F is going to be the antiderivative of all these things. Okay, how do I take the antiderivative of something? Well, I do the opposite of what I did before, right? So before I multiplied and then subtracted, I have to do the opposite thing in the opposite order. So add and then divide. So I'm going to add 1 to the power and then divide by the new power. So add 1 to the power, x to the 2/3, I didn't even add it, plus 1, divided by the new power, 2/3 plus 1, minus 5. Again, this is the same rule. Add 1 to the power, divide by the new power, plus antiderivative of 2. What's a function whose derivative is 2? 2x, yeah. Plus c. Remember, I have to put that c at the end because I could add any number I want here at the end. And when I take the derivative, it would give me this function. Okay, eventually you're going to do these enough that you're going to see the simplifying that happens. We don't leave it like this, right? Like we should do the 2/3 plus 1, and then we should do the 2/3 plus 1. But dividing by a fraction is the same as doing what? Multiplying by the reciprocal, right? So if I'm dividing by 2/3 plus 1, which is 5/3, it's the same as multiplying by 3/5. So these we are going to do a little bit of simplifying. We're going to say 4 times 3/5 x to the 5/3 minus 5 times -3/5 plus 1 is 2/5. Reciprocal, 5/2 x to the 2/5 plus 2x plus c. You could be done here. You could multiply these numbers together, right? The more you practice the easier you're going to be like, oh, this is what I know, right? Like when we take the derivative of 7x squared, we don't do 7 times 2x anymore, right? We just say 14x. So you could multiply these together. These tend to be a little bit harder when we're multiplying because they're fractions, but you know, 12/5 x to the 5/3 minus 25/2 x to the 2/5 plus 2x plus c. Okay, I'm going to do this one because I have room, and then I'll put this middle one down at the bottom. Okay, y prime is sine of x plus x to the 3/2. So to find y, I'm taking the antiderivative of sine of x plus x to the 3/2. So go back up to your chart and look for the antiderivative of sine. Negative cosine, yeah. So negative cosine x plus x to the 3/2. Add 1 to the power. So 3/2 plus 1. Divide by the new power. 3/2 plus 1 plus c. Don't forget your plus c at the end. Negative cosine x plus. In your calculator, put 3/2 plus 1 or do it in your head, whichever you want. 3/2 plus 1 is 5/2. Yeah. Dividing by 5/2 is like multiplying by 2/5. I heard like tiny words over there and I was like, I don't know what they were. Let's see. Okay, let's highlight these.
Do you have the denominator by 1?
Yeah, you always, you add both. You add and then divide by the new power. So they're both gonna have the plus ones in it.
Oh, okay.
So I did 3/2 plus 1 makes 5/2, and then I multiplied by the reciprocal, 2/5.
Why?
No, that dx was from the previous problem. Let me try to move it over on my mouse. It was over here.
Is there an antiderivative version of dy over dx?
Yeah, it would just be, you would just find y then. That's what we're gonna do next. dy dx is, it said x to the -2 minus x to the -1. Oh, I know what's happening. So then y is going to be the antiderivative of x to the -2 minus x to the -1. Okay, antiderivative of x to the -2. What do I have to do? Add 1 to the power. So -2 plus 1, divide by the new power, right? So x to the -2 plus 1 divided by the new power minus antiderivative of x to the -1. Okay, add 1 to the power. What do you get when you do -1 plus 1? 0. Can you divide by 0? No. So x to the -1 must have some other rule, right? X to the -1 is not the power rule. Be on the lookout for x to the -1. You cannot use the power rule on x to the -1. Let's scroll back up to our chart. Do any of these in this integration formula list look like x to the -1? This one. 1 over x is the same as what? X to the -1, right? This is the same as x to the -1 dx. And x to the -1 is often the way you see it because you do all that simplifying to make it look like x to a power. So when you're thinking about this rule down here, add in that 1 over x is the same as x to the -1. So when I take the antiderivative of x to the -1, I get natural log x. So add that to your rule list there at the beginning. Okay, so this guy's going to be ln x plus c. Okay, let's do a little bit of simplifying. Yeah, this 2 over 5, yep. Okay, let's simplify this first term a little bit. -2 plus 1 is -1. So this is -1 x to the -1. So y equals -x to the -1 minus ln x plus c. You could write this as -1 over x if you wanted to, but you don't have to. This answer is perfectly acceptable right here.
One last time.
Sure,
Sorry for asking you again.
it's fine.
We got 2 over 5 because we changed the sign.
Because we multiplied by the reciprocal. 3 over 2 plus 1 makes 5 over 2. But when you divide by 5 over 2, it's the same as
We only
multiplying.
changed the sign.
Yeah.
Okay.
Okay, here's some more. To do this, we're gonna have to think a little bit about our list. because I don't think we have e to the x on our list. Yeah, do we? No, we don't have e to the x on our list. Let's add it to our list. I think it's on the list at the end. Dang. I keep doing that. What's the derivative of e to the x? E to the x. So what's the antiderivative of e to the x? E to the x plus c. Okay, it's a little bit trickier if I have a number up here. Okay, if I have a number up here and it's not just x, if it's like 5x or negative 3x or 10x. Okay, so if there's a number up there, then I need to factor in that number. What would the derivative of e to the ax be? What would the derivative of e to the 3x be? What's the derivative? 3x. What's the derivative of e to the 3x?
Would that be a chain rule?
It would be a chain rule. Perfect. E to the 3x times 3. 3e to the 3x, right? So if I was going to take the derivative of e to the 3x, I would say 3e to the 3x. If I'm going to undo that, I'm going to say e to the 3x. How am I going to get rid of that multiplying by 3? Divide by 3. So it's going to be 1 over a e to the ax plus c. Okay, only if that's just a number times x. Negative 1 times x, 7 times x, negative 100 times x, 0.5 times x. And I'm going to do 1 over that number, e to the ax. So add those to your list. There's a bigger list, like at the last page today has a big list on it. Yeah, see, it's down there on this bigger list. Okay, so I'm going to do this indefinite integral. Indefinite integrals, antiderivatives are sort of interchangeable, right? So if I'm computing an indefinite integral of 3x plus e to the 2x, what do I get? Ooh, this one's tricky, right? Let's do the second part. What's the antiderivative of e to the 2x? That's the derivative. What's the antiderivative? 1/2 e to the 2x. Perfect. Okay. What's the antiderivative of 3x? What's the antiderivative of x? Which rule should I use? The derivative is 1. What's the antiderivative? I should use the power rule. What's my power now? 1. So to find the antiderivative, what do? Add 1 to the power and then divide by the new power. So 1 plus 1 divided by 1 plus 1. So the antiderivative of x is going to be x squared divided by 2. Yeah? So what's the antiderivative of 3x? 3x squared divided by 2. Yep. Okay. How about the second one? What's the antiderivative of 3e to the x? Yeah, 3e to the x. This one's different, right? Because it has the constant in the front. If the constant's in the front, it just gets to stick there. So the antiderivative of e to the x is just e to the x. Okay, how about 9 over x? You want to rewrite it first? Yeah, okay. So this is 3e to the x plus, yeah, 9 ln x. You had it. 9x to the negative 1 dx. And remember, x to the negative 1 is that special one at the bottom of our list, right? If we see it as 9 over x, then we know right away it's going to be 9 ln x. Done? Plus c. Yeah, put that like on your hand or something. Get a little tattoo right there. Plus C. Because remember, an antiderivative is an entire family of functions. Each of us could put a different value for C here and we would still have the correct answer. Because an antiderivative is something that you can take the derivative of and get back to what you started with. If I take the derivative of this guy, no matter what number I put there for C, I'm always going to get back to what I started with. Okay, last one. Antiderivative of 4x. That was good. Minus antiderivative of cosine. Sine. Sine or negative sign? It's positive sign. Yeah. The derivative is negative sign, but the antiderivative is positive sign. Okay, plus C. Well, it's negative because it was negative to start with, right? The antiderivative of cosine is sine. The antiderivative of cosine is sine. Because it was minus cosine, it's minus sine. It's opposite of what the derivatives are. Okay, I'm going to pause the video. Oh, I might be going to stop the video. I'm going to stop the video. I posted the quizzes, so you can do the quizzes after. But that's all we're going to do later.